So welcome to this module on the introduction to iVerilog and how to simulate the design and what is the test bench. We are going to have an introduction of these topics in this session. So first let us look at what is a simulator. So a simulator is a tool which is used for checking my design. So the RTL design is actually the implementation of a spec. So the intent of the spec needs to be verified by simulating the design. So RTL design is checked for the adherence to the spec by simulating the design. And the tool used for this is the simulator. And in this course, we are going to use the tool called iVerilog. So what's the design? We have already looked at it. Design is the actual Verilog code or set of Verilog codes. That means the design can be spread across more than one code or one file, which has the intended functionality to meet the required specifications. And what is a test bench? Now I have my design. I need to check whether my design is obeying to the required spec or not. So to ensure that it is obeying to the required specifications, which I'm calling as spec also in short, I need to apply the stimulus to my design and observe its output and match it to the spec. Okay, so test bench is the setup to apply the stimulus, also called as test vectors, to the design to check its functionality. So let's see how the simulator works before we get into it, because this is going to be very important couple of sessions down the line. So the way simulator works is it's going to look for the changes on the input signals. Upon every change in the input, the output will be evaluated. If there is no change in the input, there is no change to the output. That is the way simulator works. This is a very important point we need to keep in mind. If there is no change in the input, the simulator is not going to evaluate the output. That is the way simulator is going to work. So simulator is looking for change in the values of input. Okay, let's see the design and the test bench setup. So I have a design. To my design, I have a set of primary inputs. Primary inputs, there can be one or many. So inverter has only one input. Let's say for example, my design is an inverter. It has only one input. Or if it's any other design, it'll have more than one input and it'll have one or more outputs. Correct? Now to all these primary inputs, I need to generate a stimulus, and from all the primary outputs, I need to observe the stimulus. So I will have a stimulus generator and a stimulus observer. This is what I'm going to call, this is how my test bench looks like. So the design will be instantiated in the test bench, and then I will have a mechanism to apply the stimulus to the design. Okay. Note, the design may have one or more primary inputs, one or more primary outputs. This we already saw. TB is the short form for test bench. TB doesn't have a primary input or primary output. So the test bench, kindly note, there is no primary input or primary output to the test bench. Only the design has a primary input and primary output. Okay. So let us look at iVerilog based simulation flow. I have a design. I have a test bench. I apply this both to the iVerilog. And as I told you, any simulator for that matter, not only iVerilog, any simulator for that matter is going to look only for the changes in the input, and it is going to dump the changes in the output according to the changes in the input. So the output of a simulator is going to be a VCD file, where VCD stands for value change dump, because we are looking for the changes in the values. So the format is called as a VCD format or a value change dump format. Now we want to view this VCD file, correct? So we will use another tool called GTK Wave, which is used for viewing the waveform, and we will be able to see the waveform outputs. For input, for the given inputs, what is the change in the output? Like this, you will be able to see the waveform where you can verify the functionality of the design.